Good morning, student. Today I am going to discuss one of the important properties of the nanomaterials, that is electrical and thermal properties. In my previous two lectures, I have already discussed some other physical properties like optical properties and mechanical properties. Now, it is universal truth that most of the important application of nanomaterials depends upon different properties, and we generally call it is a size and shape dependent nanoparticles. So in today's lecture, I will concentrate only on the two properties, that is what is the effect of size of nanomaterials on the electrical conductivity as well as thermal conductivity of nanomaterials. As you know, when I am talking about the nanomaterials, it is related to nanoparticle as well as it is related to nanorods or the nanowires or even carbon nanotubes and other things. So it is very complex type of behavior. But because you are all M.Sc 4th semester student, so I will discuss only some of the fundamental electrical properties of the nanomaterials, and I think it is in your course in M.Sc 4th semester chemistry. So before I start my lecture, I would like to share some of the important research articles related to this nanomaterials, because my complete lecture is based on some of the research papers, and I have collected some of the electrical conductivity data and thermal conductivity data from some good research papers. So it is up to you, you can refer all those research papers for further studies and further information. Say for example, if you want to know about the effect of size on the silver nanoparticles and the electrical conductivity, you can refer this paper. It is published in American Chemical Society Applied Material and Interface. Of course, although it is one of the old paper, 2012 like that, 2012. Similarly, I have also referred for some information about the theoretical model. So it is also a very good paper. It is actually electrical conductivity of semiconducting nanoparticles. As I have already told you that nanomaterials, it will cover nanoparticles as well as the some semiconductor nanoparticles like zinc oxide and other things. So it is published in Physica B Condensed Matter, and you can also refer this paper. It is not very old paper, 2022. So a simple and comprehensive theoretical model has been presented for the computation of the electrical conductivity for nanosolids, considering the size, shape and relaxation factors is very important. And it is also very new paper related to that thermoelectric properties, because you know that phonon and electron phonon scattering is one of the important factor for this properties. So I have gone through this paper published in the Chemistry Select, and this is phonon scattering mechanism for size dependent thermoelectric properties of some bismuth Te3 nanoparticles. And the last paper I have referred is also a very old paper, but very important paper, that is the effect of lattice crystallinity on the electron phonon relaxation rates in gold nanoparticles, and it is published in Journal of Physical Chemistry C Letters 2007. So what I mean to say that there are large number of research papers available in our library also. So for comprehensive information, you can refer all those papers. And you know that Al-Sayed is a very well-known surface chemist, and this paper is very important. How the conductivity, conductance properties affected with the size and shape of these things. So first point is that you know that the properties of the nanoparticles are depend on the particle size, shape and composition. And because you know that size has a direct impact on the electrical properties. And here, as I have already discussed in my initial discussion, that I will concentrate only on electrical and thermal conductivity. And as you know that you are all aware of the conductance, the migration of the ions and other things. So whenever we are talking about the change in electrical conductivity, of course it depends upon the electronic migrations and electron mobility, electrons available in the conduction band. So that is very important, and there are other factors also. I will come later, the other properties. So why we are studying this type of electrical properties? Because you also might have heard about the tremendous application of these nanomaterials in optoelectronics or in thermoelectronic area. So a complete understanding of this electrical and thermal properties of the nanomaterial is of really paramount importance for the development of the new materials and optimizing their performance in diverse applications. And you also know various applications. In my last class, I will also discuss about the application of the nanomaterials. But while studying that optical properties and other properties, you already came across all these points. The important properties can be useful in the area of electronics, particularly biosensors, energy storage and conversion, and several biomedical devices and etc. Now I am just, before going into details of that property, I must tell you what is actually electrical conductivity and thermal conductivity. So electrical conductivity of a nanomaterial describes the ability to carry an electric current, while its resistivity measures its ability to resist the flow of electricity. This is related to the electrical conductivity. And if I am talking about the thermal conductivity, so thermal conductivity of nanomaterial describes the ability to conduct the heat, while its thermal resistivity measures its ability to resist the flow of heat. And fortunately, there is a relationship between the electrical conductivity and thermal conductivity with the temperature. I will explain that French theory, the relationship between the electrical conductivity and thermal conductivity. Now I am coming to if you ask me that what are the factors responsible for change in electrical properties or in thermal conductivity. So basically, again and again, just like your electrical properties or mechanical properties, you know that quantum confinement is very important, because when we are talking about the movement of the electrons and other things, So first point is that quantized conduction. I'll explain these things. And of course you all know that quantum confinement effect, the discrete energy levels, widening and discrete of the band gap is also related to these things. Then surface scattering is also very, very important. Surface scattering is also very important because one of the important factor is the surface scattering. Very important factor is the surface scattering. So, and Coulomb charging, and I will not discuss today the tunneling effect and other things. I will concentrate only these two: quantum confinement and surface scattering. There are many types of scattering. You know that elastic scattering or inelastic scattering, but particularly inelastic scattering is important in this thermal property like that. So, although there are many effects, but you can say that following effects are significant for the electrical properties of the nanomaterials. So you can write that one is quantum effect. So there is a continuous bands are replaced with the discrete energy levels. Band gap is changing. And second is that classical effect. That is, I am talking about the mean free path, because when there is a collision and scattering, so there is a change of mean free path. That is very important. So you can write that only two effects is responsible: quantum effect and the classical effect. Now, as you know that if I consider a bulk material, so electron can move freely, but because it is a confined in a small, we decrease the size of that nanomaterials. So energy band gap expansion restrict the easy movement of the charge carriers, and hence it is quite natural that when you decrease the size of the nanomaterials, the electrical conductivity is also decreased. So the restricted size of the nanoparticles causes a special confinement effects. Now I can give some example. As I told you that there are large number of important studies are available in the literature. I am taking one of the example of effect of particle size on the electrical conductivity of the metallic nanoparticles. So it is published in International Conference on Advancing Education Technology. So here you see that this is the electrical conductance values. The electrical conductance of metallic nanoparticles. The solid line represent the electrical conductivity of nanoparticles metals from our model, because they have applied some model, and these are some of the literature values. This blue color is the literature values, and you see that of course this is for copper thin film. So when the size is less, size is low, the conductance is also, that means there is a decrease in the conductance, and therefore they explain the effect, size effect of metal on its electrical conductivity. There are some mathematical relationships. So as he also written, the electrical conductivity is associated with electron mobility. That is the important. So behavior of the electrons in the metal plays a very significant role in deciding similarly, now if I am talking about the thermal conductivity, so I have taken this graph from the effect of particle size on the thermal conductivity of nanofluids containing metallic nanoparticles, and you see this is published in the nanoscale research letters, and you see it is thermal conductivity, the unit is also there, and this is the size of that characteristic dimension of that copper nanomaterials. So you see that the thermal conductivity of copper nanomaterials is gradually decreased with that size. Same, I am just also giving another example from same paper for the, I think for the silver nanomaterials. So you see that this is the thermal conductivity, the unit is there, they are giving this different types of value. So effect of particle size on the thermal conductivity of nanofluids containing the silver. Here you see it is 20 nanometers, then 40 nanometers, 60 nanometers, 80 nanometers and 100 nanometers. So 1% black square, this is like that, 2% black circle, like that. Experimental data of this work, and the dashed line and solid line represent the calculated value. But everywhere, whether it is a calculated value or some theoretical experiment or some experimental method, everywhere what the observation is that the thermal conductivity is decreased with respect to the size. So I have taken this information from similar examples. If you search the literature, you will get large number of data related to the size dependence of electrical conductance as well as the thermal conductivity. Now, so what I just tell you, first point I have already discussed, the quantum confinement, movement of the electron. The second point is the scattering point. This is very important, that the effect of nanoparticle size on thermoelectric properties of the nanoparticles, and can be analyzed by phonon scattering or electron phonon scattering. Because the reduction in nanoparticle size, if I decrease the size of the nanoparticles, as you all know that it increases the interface volume ratio, surface area to volume ratio, which increases the scattering of the phonons to the grain boundaries, maybe some. So an increase in phonon grain boundary scattering decrease the thermal conductivity due to the shortening of the phonon mean free path, which is very important. So now I will explain that why such type of decrease in this phonon scattering. Because there are some elastic scattering when there is no change in energy, but in inelastic scattering there is a change in energy, there is a diversion, and therefore that mean free path is also shortening and the thermal conductivity will decrease. So, but suppose you are not aware of you know about the photon, you know about the electron into electromagnetic radiation interaction, but I think you are not aware of the phonon. So if you read any physics book, phonon in condensed matter physics, a unit of vibrational energy, because there is a electron as well as the phonon interaction. So it is a unit of vibrational energy that arises from oscillating atoms with a crystal, sound waves you can call it. So I am taking from this information from Britannia or the Wikipedia or from Britannica. The actual definition, a phonon is a definite discrete unit or quantum of, just like a photon is a quantum of light, so it is a quantum of vibrational mechanical energy, you can call it. So just as a photon is a quantum of electromagnetic light energy, here it is a vibrational mechanical energy. Both is very important here. So phonon interaction and phonon electron scattering, like that. So the summary is that high electron phonon scattering and phonon scattering in nanomaterials are responsible for the reduction of the conductivity. That is the final conclusion of this thing. Or as I told you that there are two types of scattering. One is elastic scattering, another is the inelastic scattering. And as per the literature, that elastic scattering does not affect the conductivity, while inelastic scattering decreases the conductivity. That is the important point. And the last part I just want to tell you that there is a relationship between the thermal conductivity and the electrical conductivity, and is a very popular law available in any physics book, that is called the Weidmann-Frange law. And if I consider K is the thermal conductivity and electrical conductivity I can sigma, so there is a linear relationship, because you know that the ratio K, and that means ratio of the thermal conductivity and the electrical conductivity proportional to the absolute temperature. So this is directly proportional to the temperature. So if it is increased, so naturally, because, or I can write K is directly proportional to the electrical conductivity, and that is a Lorentz number. The unit is like, the unit of thermal conductivity is like, unit of the general electrical conductivity. So I will not discuss about the Weidmann-Frange law, but you must know that the relationship between the thermal conductivity and electrical conductivity. And sometimes what happened, the crystal defects is also very important. So first is quantum confinement, quantum conduction, second is the scattering effect, and third is also sometimes crystal defects and dislocation and increased perfection. That means there is a reduction of defects also affects the conductivity. That means it is a quite natural law that when we decrease the size from bulk to nanomaterials, the size, as we decrease the size, the defects will be very, very less. So therefore it will also affect the conductivity. So let me summarize the things that today in this very short lecture I have discussed the thermal and electrical conductance of nanomaterials. As I already pointed out that it is a very complex type of things, but for M.Sc student I have collected some of the very simple information. I have also shown him some of the data related to the role of or the size of this nanomaterials with respect to observed conductance, electrical conductivity as well as the thermal conductivity. In my next class, I will discuss the magnetic properties of the nanomaterial. Thank you very much.